Hi, okay, welcome back to chapter 3. So today we're going to look at measures of dispersion. Okay, so previously in chapter 2 we looked at measurement of central tendency, which was mean, mode, median. So now we will look at measure of dispersion, which is actually, what is dispersion? Dispersion is actually how dispersed something is. How far apart is it? Okay, the distance between one another, that means it's all over. So we want to check, we want to measure how dispersed your data is. So logically, the more dispersed your data is, it's not that good. You want a data that is less dispersed, that means which is closer to each other. That shows your data is more accurate. For an example, if I actually collect data of height of people, and I get one that is so short, I get one that is so tall, you know, your data is dispersed. You want something where it's all in the same range, all right, and they are mostly close to each other. That's a good set of data usually, all right. Okay, so let's look at our learning outcome for today. For this class, I would only cover the first two, which is the meaning of measure of dispersion. I'll tell you what is range, interquartile range, variance, and standard deviation. I'll explain each one to you what it means. And then measure of dispersion, I'll teach you how to calculate using all three of the data, and just like chapter 2, ungrouped data, group data without intervals, and group data with intervals. I'll teach you how to calculate them. All right. Let's just look into your manual. So these are the same learning outcomes that you'll be looking at in your manual. Okay, we will do the first four. All right, box and whisker plot, which is actually box plot as well. We will only do it in the next class. All right, so today I'll only cover the first two. So let's look at measure of dispersion. What is dispersion? Like I told you just now, refers to the variability of the distribution. What does variability mean? That means how different is it from one another. Like I said, I've got a big variety of food, a variety, variability. They all mean the same thing, of different kind. They are spread out. Okay. How spread out or scattered from its average value. That means if my average is 80, for an instance, how far is it my data is from 80? Usually we want most of our data to be close to the average value, because average basically tells you the story of what's going on in the question. Like I take your marks, for instance, I get 82%. So what tells me is most students did all right. Everybody got A. Most of them got 80 plus. That's what it tells me. You understand? Okay, so you basically, that is your judging point. You look at your mean and see how far each data is from the mean. The closer it is, the better it is. All right, so how far is the data spread away from the mean? This is what I was talking about. So there are four measures of dispersion, MOD. Like earlier we learned MCT, which is measure of central tendency. You had mean, mode, median. Now you have measure of dispersion, which is range, interquartile range, variance, and standard deviation, of which you probably have heard of range, variance, and interquartile range. You've probably done it in school before. It is only interquartile range is something new to you. But you don't worry, I will teach you one by one what each one of it is. Same rules apply from chapter 2. All calculation for decimal place. If you are, this is very important. If you are transferring value from one calculation to another, like when you calculate standard deviation, you're going to use mean value inside there. It must be transferred in 4 decimal places. All right. It must be transferred in 4 decimal places. All your final answers, it will follow the same as chapter 2. Discrete data, 4 decimal places. If they don't give you a story, if they tell you the story, then it's a whole number. All right. Continuous data, 2 decimal places with units. Okay. Now, when the MOD is large, that means the measure of dispersion is large. What does that tell you? I'll just bring this down so you're able to see. Measure of dispersion measures how far the data is spread away from the mean. This is explained to you earlier. So if your measure of dispersion is big, that means my range is big. That means my smallest value and biggest value is very far from each other. So the data is spread further away. The spread of the data is big. That's what it tells you. So in a nutshell, right, you want your MOD values to be small. That is ideal. All right. So your data has high variety, which is not good, you know. Like let's say I take results for instance. Again, one student get only 10 marks. One got 100, got 80, one got 20 marks. So that's high variability, which is not good. Okay, and which reflects on low consistency. This is what I'm saying. You see, like now, I'm a teacher, okay, and I take all your marks, for instance. I get some who get 100, 80, some who get 0, some who get 10, meaning my teaching didn't do anything. The consistency of the data is bad. Okay, and that means I'm not a reliable teacher, in other words, or I can't rely on that data. Okay, another example is, let's say I have students, athletes, you take their time they take to run from point A to B. Okay, so this particular athlete, the first time he runs for 10 seconds, the second time he runs he takes 20 seconds, the third time he runs he takes 10 seconds. He's not reliable. All right, so you always look for a data which is consistent. So in other words, whenever it's consistent, your MOD is low. Okay, so if you look, this is a histogram. You have been drawing this, you should recognize this. Okay, so if you look at this, this is less dispersed, this is more dispersed. Okay, so when your data is all over the place, it is considered more dispersed. When your data is all together, you see the smallest value is 10, the biggest is 14. It's close by. Here the smallest value is 2, the biggest is 9. So it's very far, no? So you don't want something that is dispersed. You always like something that is less dispersed, meaning it has a low standard. This sign that you see here, right? This is standard deviation. This sign here, this is standard deviation sign. This is mean, this is standard deviation. This one with the square there is variance. Okay, now I will show you what is range. I'll explain to you one by one what each is, all right? So let's look at range. What is range? You take the biggest value in your data, or in other words, the maximum value in your data, minus the minimum value in your data, the smallest value lah. Okay, for group data with intervals, you take the upper boundary, that means the highest boundary minus the lowest boundary. Okay, so let's look at this. What is the advantage of a range? You can quickly see the dispersion of the data. That means you just look at it like just now. Remember, I told you, oh, the biggest is 14, smallest is 10, biggest is 9, smallest is 2. From there you can see, oh, here my range is 7, here my range is 4. I pretty much know, very fast you can see that this should be less dispersed. So rough measure can be easily understood and calculated. But what's the disadvantages? Where your biggest and smallest values, sometimes they are extreme values. So when we do box plot, you'll be introduced to something called an outlier. You were already introduced to extreme values, right? In chapter 2, where the value was too big. That's what you call an extreme value. So when your value is, maybe that just that one value could have been wrong, but you're using that to calculate your range. So it might not be accurate. Okay, maybe that one value only wrong, but when you calculate the range, your range will be so big. And you'll be like, oh, that means my data is dispersed. Actually, probably only that one value is wrong. Okay. So let's look at this. Okay, I'll just show you your manual and show you where we are right now, so you can follow me closely. All right. So we are on page 73. Okay, I'm on page 73. I'm actually going to do the ungrouped data right now. Okay, so you sort out, actually you don't want to sort also, it's okay because it's pretty obvious. Just take the biggest value minus the smallest value, which is 0. 7 minus 0, your range is 7. Group data without interval. Take your data, not frequency. Students always make this mistake. What's the range? Oh, my range are 8 minus 1. Wrong, huh? You have to take your data minus the biggest data minus the smallest data, not take your frequency. So what's the data here? 5 minus 0, which is 5. So in your manual, we're actually doing this question now. Okay. Group data with intervals, how to find range? You look at the biggest boundary here, 70 minus 40 is 30. That's it. Okay. Now let's look at something called IQR. IQR, in other words, is interquartile range. Show it to you. So this is what we are looking at. What does interquartile range do? Okay, it refers to the spread of the middle 50% of the data. You know why or not? Actually, what we are doing is this. Your total is always 100%, right? So we are actually dividing the data into 4. 25%, 25%, 25%. You will understand this a little bit more better when we do box plot. Okay, so basically what we're doing is we're just dividing the data into 4. Okay, the first 25%. That means we arrange from small to big first, and okay, this is the first 25%, second 25%, third 25%, fourth 25%. Okay. So what we are going to do is we are going to, like you see, range, we take the biggest value minus the smallest value. Interquartile range, we are looking at the middle 50% here. That is what we are doing. We are going to take the third quartile minus the first quartile. We're going to take the third quartile minus the first quartile, which is Q3 minus Q1. In other words, the third quartile is also known as upper quartile minus lower quartile, Q1. Okay? Alright, so let's look at what are we looking at, the advantages and disadvantages. Okay, basically, why are we doing the middle 50%? Because just now I told you what, when we calculate range, we may take in the extreme value, right? It may happen. So now we are taking the middle 50%. Why? Because the extreme values are either this side, very big, or very small. So we are looking at the middle of the data to see how is your spread. Okay, so what's the advantages? Not affected by extreme value. You don't need to worry about all this theory. You won't be tested. I just need to tell you what you're doing. Alright, so it won't be affected by the extreme values because it's in the middle of the data. Extreme values can only be either in the big N or small n. Okay, it can only provide information of the difference between the first and third quartile. It can't give you much information. Okay, so let's see how to calculate IQR. So in our manual, we are on page 75. Okay, so when it's ungrouped data, you got to rearrange it from small to big as usual. Okay, so this is very similar to what we did in chapter 2. So that's what I'm saying. If you don't know how to do chapter 2, right, you'll be totally lost when it comes to chapter 3 because it is connected. All right. Okay, so basically this is data number 1, data number 2, data number 3 is just the numbers for you. All right. So we have sorted the data from small to big. Okay, so now how do we are going to go back, reflecting back. How to find median? How do you find median? N plus 1, right? How to find median? N plus 1 divided by 2, correct or not? Or times 0.5 is the same thing. You times 0.5 or you divide by 2 is the same thing. So you get 10.5. That means between data 10 and 11, my median is 14. How to get 14? 13 plus 15 divided by 2. Correct or not? This is what we did in chapter 2. So we're going to apply the same method, exactly the same way. Okay, but the only difference now is we want to find Q1 and Q3. So what's Q1? I told you just now, the first 25%, right? In other words, 1 over 4. Okay, so do you see N plus 1 times 0.25? Why 0.25? I want Q1, the first quartile. Or either you want to times 1 over 4, it's up to you. You want to times 0.25, you want to times 1 over 4, totally up to you. So you will get 5.25. A lot of students, oh, 5.25 is my Q1. Wrong. 5.25 is the position of your Q1, meaning my Q1 is between the 5th and the 6th data. Whether it's 5.25 or 5.75, it falls between that two. Don't go and round off. Oh, 5.25 means 5th data lah. No. The moment got decimal, you take both the values. So 5th and 6th data, you take the average, which is 0. Okay, then you want to find interquartile range. You don't need to do Q2. The reason the Q2 is here to show you that the method is the same. Okay, the method is the same. Alright, so Q3, what's Q3? I told you just now, 75%. So same. You want to take N plus 1 times 0.75. You want to take N plus 1 times 3 over 4, up to you. So 15.75, meaning my Q3 is in the 15th and the 16th position. Don't go and say, oh, it's 15.75, so I round off to 16. Wrong. Students always make this mistake. So 15th and 16th data, 28 plus 30, that divided by 2 gives me 29. How to find IQR? A lot of students are actually, their main mistake here is they find Q3, they find Q1, done. They don't minus and find the interquartile range. So don't go and do all the hard work and then you forget. So Q3 minus Q1 is 29. Alright, everybody okay there? Okay, so that's how you find IQR for ungrouped data. Okay. Alright, so whether it's odd number of data or even number of data, the way we are going to do it is the same. It's always N plus 1. Then you take that, either you times 0.25, either you... So it's just that sometimes you get a whole number, sometimes you don't. So you just follow. If it's not a whole number, you take the two values. Like it's 5.25, you take between the 5th and the 6th data. If it's exactly 5, take the 5th data. If exactly, okay. If decimal, you take 2 values and you add up. Okay, same thing goes to group data without intervals now. Same, the way you calculated your, basically the way you calculated your median, same method. All right, so total frequency is 20, total frequency plus 1, same, you're going to use cumulative frequency. So that is why I kept on actually emphasizing that you must know how to do chapter 2, because concepts remain the same. Okay, whether it's odd number, even number, we're going to use same way. You're going to use cumulative frequency. So how you find median? 21 times 0.5 or divided by 2 or times half, right? You get 10.5. Between data 10th and 11 data, use cumulative frequency inside here. So my median is 2. So you're going to do the same thing for Q1 and Q3. The only difference, you times 0.25 or you get 5.25. Between the 5th and the 6th data or inside here, Q1 is 1. What is Q3 times 0.75? 15.75 between 15 and 16 data. Where's my 15 and 16 data? Inside here. Okay, Q3 2. No problem. Q2, Q3 can be the same. No problem. Don't, hey, same or wrong? No. IQR 2 minus 1. Q3 minus Q1. You don't need to find Q2 for finding IQR. It's just here to show you method is the same. Only that median is half. Q1 is 1/4, Q3 is 3/4. Whether you want to use fraction or decimal, up to you. Okay? Now, group data with interval. So let's go back to the manual to see where you are right now. We are on page 78. So finding IQR using group data with intervals will be the same method as chapter 2. Nothing is so different here. Okay, so when you have group data with intervals, there are two ways. If they ask you to calculate, you use formula. They ask you to estimate, you will use your ogive. Okay, all right, so let's look at this. You have group, I'll use this because it's easier for me to show you the whole picture. So basically, same method. When you had group data with intervals, right? Chapter 2, how did you calculate median? N plus 1 divided by 2, correct or not? Let's see down here. It's not here. Okay, n plus 1 divided by 2. Then you find which, use your cumulative frequency, like 46. Then your cumulative frequency is 23. Then you see in which class. That is your median class. Then you apply formula. Same method. Okay, same method. So we need to determine our Q1 class first. Total frequency plus 1 divided by 4, or you want, or basically just, or you want to take total frequency plus 1 times 0.25, all same. So you get 11.5. What is 11.5? Between the 11th and the 12th data. So go back here, use your cumulative frequency. 11 and 12 data is where? Inside here. Which is, that means my Q1 class is between 3000 and 3500. How to find Q3 class? Same. Total frequency plus 1, you want to times 3/4, you want to times 0.75, up to you. So you will get 34.5. Okay, so it's between the 34 and 35th data. So you go here and you see where is 34 and 35 data, which is inside here. Okay, so your Q3 class is 3500 to 4000. All right, so there's actually a mistake here. This should be 34 till 35, right? So 3500 and 4000. So now you're going to apply the formula. So basically, let's put this a little higher. All right, so basically the formula is the same. All formulas are given to you. No need to worry about this. They will give you Q1, Q2, Q3. Q2 is basically your median lah. So you just follow what the formula means, also the same. Okay, so lower boundary of your Q1 class is 3000, right? 3000 plus 1/4, total frequency is 45, minus cumulative frequency before your Q1 class. Cumulative, this is my Q1 class, that's 10, divided by frequency of the Q1 class, which is 18. times 500, the size of the class. That's how you find Q1. Same goes to Q3, 3500, it's my lower boundary, 304 times 45, minus cumulative frequency before my Q3 class, divided by frequency of the Q3 class, times the size of the class, you will get it. So you take Q3 minus Q1, you will get your IQR. So 3680 minus 3035. Okay, so a little bit more extra work when it's group data with intervals. All right. So now when they ask you to basically estimate is when you use your ogive. So what is Q1? 20. When we learn ogive, right? When you estimated median, how you did it? 50% come down, right? What's Q1? I think I'm going to move this bit out. Okay, so what's Q1? 25% come down. What's Q2? 50% come down. What's Q3? 75% come down. So it's an estimated value basically. All right, so all of you will get a slightly different value. So in order for you to check if you have done it right, then you just basically use the formulas. All right. Okay, so now let's take a look at this. So your measure of dispersion is looking at the spread of the data like I told you, all right, from the mean. Okay, so if the spread of the data, how will it change? If the spread of the data change, your standard, this is standard deviation, standard deviation also will change. So now this is the last measure that we are going to learn, which is standard deviation, something that you have learned in school. So what does standard deviation mean? Okay, that means, it basically means whatever it is, how much each data deviates from the standard. Your standard is your mean. You're basically calculating the distance between each data from the mean. That is what standard deviation means. All right, if the spread of the data change, your standard deviation will change. If you remove outliers, for instance, what is change in spread is what I mean. Let's say I have an extreme value that was wrong. I take it out. My standard deviation will change. Understand? Standard deviation cannot be negative. Why? Standard deviation cannot be negative because it is a square root. You cannot have a negative value coming out from a square root. Understand? Okay, let's take a look at this. So this one, your standard deviation be high. Very easy to see. You can see your range is what? 8, surely big. Here my range is what? Smaller, right? Surely small. Here I only have one data which is 5. So what does that tell you? My mean also will be 5. My standard deviation 0 lah. No distance, right? Each data no distance, right? Only 5, only same data. So no dispersion. Your data all the same. So no problem. Okay? So this is your formulas. Don't worry. Formulas are given to you. Nothing to memorize. What is this? Sigma x squared. So before this, when you did mean, you have sigma x, right? You total up your data, then you divide with the total number of data, and so on, right? So now you have sigma x squared. Don't worry, I'll show you what it means, okay? Sigma x squared over total data, total number of data, minus this is mean squared. This sign that you see, symbol you see here is mean. This is sigma fx squared. Don't worry, I'll show you what it is. Divide total frequency minus mean squared. Okay, group data with interval. What is that? Xi, I taught you in chapter 2. That is midpoint. Okay, then you have mean. All right, so let's take a look. What is the advantages? This is the best measure of dispersion. It is the best. There is no weakness. Why there is no weakness? Because it takes into consideration every data, the distance of every data from the mean. Okay, I need to show you one example how to calculate. Let's take a look at page question 2, exercise 3.1 on your manual. It will be on page 83. Okay, so this is group data with intervals, right? This is a histogram for you. So you need to come out with your table first. So you come out with your frequency distribution table. Write down the frequency. What you need to add, this is group data with intervals. From chapter 2, I already taught you. You need what? Two things, right? Midpoint and FXI. What is midpoint? The middle of the data. What's FXI? midpoint times frequency, midpoint times frequency, then you total and put it down. Now they've asked you to calculate standard deviation. So if you look at the standard deviation formula, what do you need? Sigma fx squared. A lot of students get this wrong. You know what they do? They take 1800 squared. It's wrong. What is fx squared? Frequency times midpoint squared. 1 by 1, which is 40 times 45 squared. Then you write down. 18 times 55 squared. Then you write down. 27 times 65 squared, then you write down 1 by 1. And what I want you to do is always write the total here. Total out fxi, total out fxi squared. Why do I ask you to do this? Because when you want to put in the formula, just put it in. Fx squared, 915,000 over total frequency 184 minus. Okay, now this is mean, right? I know you know how to find mean. You already find here. You cannot put 69 inside here. Cannot. Inside here, in this mean, either you transfer in 4 decimal places, meaning this value, or you put the whole fraction in. How to find mean? You take this value, this last value here, 12630, divide 184, right? So you put the whole fraction in. So again, I'm repeating, either you replace with 4 decimal place or you put the whole fraction in. And when you do this, I don't want you to do this step. This step is here just to show you what is variance. I want you to put in the calculator one shot and solve it. Okay, those of you using the silver calculators, you should be able to put it in one shot. It's easy. Those of you using the black calculators, please make sure you put brackets and so on in the right places. So black calculators, you put this in first. That means 12630 divide 84, answer. Answer you square. Then you take 915,000 divide 184 minus answer, square root answer. Do it step by step. You have a problem, you let me know. I will video it and send it to you. Okay? So this is variance. I've only shown this step because I want to show you this is variance. But if not, please skip this step and straight away give me the standard deviation. Okay, so before you, the value that before you square root, that is your variance. So don't repeat and ask me, Miss, I don't know how to find variance, because students always forget one. Okay, so now this is number of patients, therefore it's rounded off to a whole number. Can all of you see that? Okay, so that is how you calculate variance for group data with intervals. So group data without intervals, a little bit more easier. Same thing, fx squared you have to find. So frequency times data squared. I'm repeating, frequency times data squared. So you do 1 by 1. Frequency times data squared. 10 times 1 squared. 59 times 2 squared. 102 times 3 squared. Do you understand? Okay, then you plug it, see, plug it in. That's why I always like students to write a total on the bottom. Whenever you write a total, you will never go wrong. So you fill up the values. Please skip this step. This is just to show you the variance is 2.2346. So your standard deviation is 1.4949 and you have one member. All right, round off, follow normal rounding rules. So let's look at group data without intervals. How to find your standard deviation? Square 1 by 1, no choice. You got to square 1 by 1. 1 square plus 3 square plus 4 square plus 5 square plus 7 square, 7 square plus 1 by 1. Total will be 2159. Divide 15 minus 15 square. Okay, so for today, I want you to finish page 82 to page 90. Alright, in the next class, we will continue with box plot. If you have any questions, please ask and I'll help you right away. Alright, this is a fairly important chapter. Your exam actually has a very high weightage of this chapter. Alright, so we will stop here and in the next class, I will continue with box plot.